Hey folks, I'm Jen Foxplot and welcome to Maker Quest. In this episode, I'm going to talk about temperature. So temperature is one of those phenomenon that's pretty familiar. We have to deal with it every day. But what is temperature really? Well, so the definition of temperature is the average amount of heat or thermal energy in a given substance. And since it's the average amount of thermal energy in a substance, the size of the sample doesn't really matter. So for example, if you have a small pot of boiling water, it's going to be at the same temperature as a large pot of boiling water, as long as you're at the same altitude. So macroscopically, or in the world of things that we deal with, it's a pretty simple phenomenon. Hot, cold, we get it. But what's really interesting is when you get down to the molecular level, because that's really where temperature does its thing. And so temperature is actually a result of the kinetic energy of molecules. So every substance is made up of molecules and atoms, and so the temperature of that object is determined by the kinetic energy of those atoms, or literally how much they're moving around. In general, gases have higher energy atoms because they have more kinetic energy. Solids have the lowest amount of kinetic energy because they're more rigid and the molecules are more confined. And liquids are in between gases and solids because they're able to slosh around, but not as much as gases. But okay, so then you might be asking, well, why is the temperature of the air the same temperature as this container? They're in the same environment, so they must be the same temperature, right? So yeah, exactly. So the tricky part is that lighter molecules need to have more kinetic energy to have the same temperature as heavier molecules. And really all that is just energy. So in essence, that means that to have the same temperature, a lighter object will need to have a higher kinetic energy of its molecules. To illustrate that, I have 4 screws in each of these containers. This one is filled with larger screws and this one's filled with smaller screws. So when I shake them, if I shake them with about the same amount of energy, the larger screws will make more noise because they're more massive, and the smaller screws will make less noise. So that's kind of the same concept as temperature. If you have lighter molecules, they need to move around more to be at the same temperature as heavier molecules. So basically that means that the molecules in the air are lighter than the molecules that make up this container. How does temperature get transferred? Well, you probably know that over time your coffee gets cold. And so what is really going on is the coffee in the cup is in contact with the coffee cup, and the coffee cup is in contact with the air. So over time, the air molecules are knocking into the coffee cup, and the coffee is knocking into the coffee cup on the inside. And so over time, the hot coffee molecules are transferring their energy to the molecules in the coffee cup, which in turn is transferring its energy to the air around it. So unfortunately, my coffee cup is losing its heat to the air around it, so the air gets slightly hotter, although probably not noticeable by you or me, and my coffee loses heat. And so that's how temperature flows. It flows from high energy or high temperature to low energy or low temperature. And you can kind of illustrate this when you put 2 objects in contact like this. Woo! Oh no, I think I lost one. Yeah, so eventually you get the same average temperature in one substance. Cool. All right. So what about the cool thing, fire? What's that all about? Well, to illustrate, oh wait, I'll put my safety goggles on. To illustrate, I get to light something on fire. Okay, so why is this side of the paper cold and this side of the paper way hotter? Well, essentially, burning something is a chemical reaction that causes 2 atoms or molecules to fuse and release some of that energy in the form of heat and light. And so actually, we use the property that light is essentially a form of temperature to generate light bulbs. And I'll leave you with a question, which is kind of an extension of the concept of temperature, but it's something that seems to come up a lot. So I thought I would ask you to get the gears turning in your head. And my question to you is, how do airplanes generate contrails? And contrails are those cloud trails that you see behind an airplane, behind the path of an airplane. So what are they and how are they created? So think about that. And to answer last week's question, I asked, what is the actual microcontroller on a microcontroller board? Or what's the brain of the board? What's controlling everything? So maybe a simple question if you're pretty familiar with microcontrollers or familiar at all with electronics. But what I really wanted to get you thinking about was the actual physical components on the board, and to realize that, oh, the board is just essentially what's called a breakout board to make using the microcontroller a lot easier. So the microcontroller is going to be the largest black IC or integrated circuit on the board, typically. And they're usually labeled. A lot of the ones on microcontrollers are Atmel chips, so it'll have like a little Atmel label. And they always have a lot of pins around them that are soldered to all the different components and extra peripheral functions on the board. Please let me know if you have any questions about that explanation or about temperature. Like burning stuff, always fun. All right, so I'll leave it there for now. Thank you for watching, and please subscribe.